workbook, which include like solving 2-variable systems, solving nonlinear systems, and solving the 3-variable systems. But these are like all of the word problems mixed together. So at the very top of your notes page, you can see a list of things to check over at the beginning. I'm just going to talk about those steps and then give you some things to like maybe star or highlight so that you really focus on them. In that first bullet point, obviously you're going to read the problem and try to identify some important information. Know that it's always possible for a problem to give you things that you don't need to solve. So you'll kind of have to sift through as you're reading. This will be important in this equation. I'll use this in another equation. And maybe there's some information that doesn't go into an equation. So you would have to make that decision. Now, I went ahead and bolded and underlined the second part of number 1. So if you could like mark something somehow on your papers just to make sure like you need to focus on what it is they're asking you to find. Number 1, so you answer the question that I'm asking, because that's the answer that I want. And number 2, it's going to help you with the second bullet point, which is defining your variables. So there's this thing that happens later on in the chapter, like on Monday, where there's some things that are unknown to you, and then the problem will start labeling things with letters. So it will say like brand A, brand B, brand C. And then it might say more things about this is X, this is Y, this is Z. Your job will be to decipher what are actually the unknowns. And so if you look back at the question, whatever the question is asking you to find, that's going to help you figure out what you don't know and what should be marked as a variable. So like sometimes you'll see things like brand X, brand Y, brand Z. That doesn't mean those are variables. And so we'll have to be really, really careful with that. So that's why I put number 2 there. We did this back with our roller coaster project. Remember at the very beginning of your roller coaster, you defined your variables. X was time in how many seconds per unit, and Y was height in how many feet per unit. We're not going to have to worry about that per unit part here. We just want to make sure that we all agree, like this is what X is, this is what Y is. Okay? These are the things that I'm trying to find. These are the things that are unknown to me. I recommend when you're writing these types of problems and word problems, I like to use variables that go along with the story, right? So if I'm doing like adult and children tickets, I'm going to use A and C. That just helps me when I'm writing my equations and reading my equations back to myself to confirm I did it correctly. After you do those first 2, I mean, the rest of it actually works out pretty nicely. It makes it easier to write the equations if you identify your variables in the beginning. Okay? And then you all have to decide how many equations do you need. Do you need 2 because you have 2 variables? Do you need 3 because you have 3 variables? Okay. You can solve using any method of your choice. That could be substitution or elimination. Okay, you decide. And then I would put a little star on the last bullet point. Write and label your answers. When the problems of our systems are without context, we always want to write our answers as ordered pairs and ordered triples, and we need all the answers. When it's a word problem, focus on the question that's being asked of you. You may need to find all the variables. You may need to find only one variable. And when you give my answer, or when you give me the answer, that should be in context of the problem. So there should be some kind of label there, okay, so that I understand what it is you're talking about. Okay. So whether you write them as ordered triples or ordered pairs at the end in these application problems, that's not as important. Okay, it's that you answer the question that's being asked. So what I'm going to have you do is read through the first example and identify your variables, what you choose to use for your unknowns, and then write the equations. And while you're doing that, like, have a conversation with your group, see if your group members agree. You guys could use different letters if you wanted to. And then you can start solving. In a few minutes, I'm going to interrupt and put, like, what I'm seeing from the groups. So right now, you're just working and coming up with your own. So go for it. Okay, I'm going to interrupt and ask about defining variables. So first of all, if I were approaching this problem, so if you just pause your work momentarily, that'll be helpful. We'll just kind of talk and then we'll go back to work. If I were approaching this problem, I would read through the problem, try to pick out important things as I'm reading, maybe underline prices or things like that. But at the very end, I would focus on the question that's being asked. So what do you want to find? How many general admission passes did Vallis sell? Oops. Not what I wanted to do. Okay. So that is unknown to you if that's the question. So when I'm trying to define my variable, one of my variables has to be for the number of general admission passes. So I'm going to use a G for that, just so that I know G goes with general admission. I saw a few X's out in the room, which is totally fine. Okay, so this is the number of general admission. And I need to go back through the problem, even though that's the only thing I'm being asked to find. Are there other unknowns to me, things I don't know? What's the other unknown? The number of adventure passes that were sold. Okay, so we could call that A. If you used X and Y, that's totally fine. Okay, so A equals the number of adventure passes that were sold. And there really isn't another unknown to us. Okay? We don't have anything else that we would need to find. So now I can start to write my equation. Okay? One thing that's obviously going to stand out to me when I read this problem is all the money. So the price of the general admission, the price of the adventure, and the total amount of money that Vallis took in that day, that's all going to go together in one equation for money. So as I walked around the room, a lot of people find it easy to write this equation at the very beginning, 8.95 times G for every general admission, plus 23.95A for every adventure admission, equals the total amount that we sold. The other equation sometimes can be elusive to us, but it's actually like a very simple equation, and it happens a lot in these types of problems, where they just make a quick statement about the total number of stuff, whatever your stuff is. In our case, our stuff is our variables, general admission passes and adventure passes. So if I go back and reread my problem, somewhere it says, I took admission from 60 people. Now, do I know what those 60 people bought? No, they could have been adventure or general, but they came into Vallis. So there's usually another equation, doesn't have to be, but there's usually another equation that's like add everything up and equal it to the total. So in this case, our equation would look like what? Yeah, G plus A equals 60. Now, some of us are already on the road to solving, some of us have already solved. I'm going to put this question to the groups. Whether you choose to solve by elimination or substitution, totally up to you. But this is your third or fourth go-round with solving systems. So I think we're at the level where we could start asking ourselves, can I work smarter, not harder? Okay. So in terms of working smarter, focus on the question that's being asked. I want to find the general admission tickets. If you solve by elimination, how can you work smarter, not harder? Eliminate adventure pass. You don't really care about the adventure pass. So if you eliminate A first, you will immediately solve for G and you'll be done with the problem. Okay, so Brian says eliminate A. So if you're going the elimination route, work smarter. What if you're going the substitution route? So in order to do substitution, we're probably going to solve our green equation for one of the variables. If we're trying to answer the question about general admission, are you going to solve for G or A? You're going to solve for A. Someone said that over here. I'm not sure who. Jackie. Jackie tells you solve for A, so A is equal to 60 minus G. And then you can plug that in to the first equation and everything will be in terms of G. which then will find your general admission. So if you haven't already solved, maybe think about those things. And I'll come around and kind of look at the work from the group, and then we'll showcase our answer and move on. Okay? So if you need to solve, go ahead and do that now. Okay, so the final answer to the valid question should be G equals 35 general admission tickets. Make sure that you have labeled that problem or that answer for me. In all of your word problems, you want to give me a label, give me context of what we're finding. If you found out that the number of adventure passes was 25, that's fine, but that doesn't address the answer to my question. So whether or not you say anything about adventure passes, I don't really need to know it. Okay. Any questions about that first example? Yeah, Hannah. Oh yeah, so like that would be, so that's my version of working harder, not smarter, although it's not really that hard. It's just that if you solve for A first, through elimination or through substitution, you will still have to plug A back in to find G. But if we think about that before we start solving, we can eliminate that extra step, which some of us may like to do. But no, it's fine if you find A on the road to G. Okay, now I'm actually going to skip example 2. I know some of you went ahead and started working on example 2, which is great because it's another good example. It's actually on the homework as a non-required question. But I want us all to go to the last page. Okay, so we're going out of order here. There's an article here about, what is it, the track team. Okay. And you want to write a linear equations to model the data and then solve to find how many athletes finished in each place. So again, I want you to take the time to try to do this because this is the skill we need to work on. Can we read and can we write the equation? Because we need to be able to do that. So I'm going to give you some time. What I would do is kind of read through and figure out what is the question asking, so what are my unknowns, how will I define my variables, and then use those variables to write the equation. So I'll give you some time to do that, and we'll check back in and make sure we all have the same equations. Okay, so I'm going to interrupt your work just momentarily to kind of go over what I'm seeing as I'm walking around the room. So you can use X, Y, Z, A, B, C, whatever you want for your variables. Again, I would choose to use some kind of letters that mean something for the different unknowns. So I'm going to use F for first place, S for second place, and T for third place. That just helps me read my equations better when I want to go back and check them. So in the problem, we find out that there are 20 individual event placers. So that's all the first place, second place, and third place combined. So that's that equation where you just add everything up and it's equal to the total. Then there's some information about points. They've earned 68 points, and they get 5, 3, and 1 for their place respectively. So that's my 5S plus 3S plus T equals 68. And then there's a third statement here. Because we have three variables, you should be looking for three equations that you can solve. It says there are as many second place finishers as first and third combined. So first plus third must equal the second placers. Okay. Now, as I walked around, I saw some people change this for their solving strategy. If you want to solve it like we've solved all of our three variables up to this point with elimination, you could like subtract the s to the other side, or you could subtract f and t, and one side is equal to 0, so that could be your third equation, and then you can do like eliminate a variable. This one also, I would say, I would maybe solve it by substitution. So in this third equation where I have f plus t equals s, I can sub that in for s in the first two equations. If I put f plus t in here, my equation will simplify to 2f plus 2t equals 20 in the first equation. If I sub in f plus t for this 3s, that'll be 3f plus 3t. So I'll distribute the 3, and that'll give me 8f plus 4t equals 68. And I could solve that two-variable system. But if you want to do like we did before with elimination, you can do that. Okay. So I'm going to put up my answers as well so you know what my answers are. You can work on that to see if you can get those answers. Once you finish that, you can either work on example 2, which is on the homework sheet, or you can go to the textbook and do one of the first problems on your homework. So I want everybody to do their homework. So if you want to get started, you can. I'm going to say my answer to this is 7 first place finishers, 10 second, and 3 third. Everybody should be working on some form of pre-calculus until the bell rings. Whether you're finishing this problem, starting the second example on the first page, or working on your homework.